Invention 2. The story of the transistor invention. In the middle of the 20th century, the world was experiencing a rapid growth in communication and technology. Telephones, radios, and early computing machines were spreading, but they all depended on vacuum tubes to work. These glass tubes could amplify signals and switch circuits, yet they were big, fragile, and wasted a lot of power. They burned out quickly, produced too much heat, and made machines bulky and unreliable. Engineers and scientists knew that if humanity wanted smaller, faster, and more dependable electronics, something entirely new had to be invented. And the pressure to find a solution grew stronger each year. The problem was clear. Vacuum tubes were holding back progress. Imagine carrying a radio the size of a suitcase, or a computer that filled an entire room, just to solve a few calculations. These limitations meant that advanced technology could not easily become part of everyday life. The dream was to create a device that could do the same job as vacuum tubes, but smaller, tougher, and more efficient. Researchers believed that semiconductors materials like silicon and germanium might provide the answer, because they had special electrical properties. But no one knew exactly how to use them to build a practical electronic switch or amplifier. At Bell Telephone Laboratories in Murray Hill, New Jersey, a special team was formed in the mid-1940s to explore this idea. William Shockley, a strong theoretical physicist, John Bardeen, an expert in quantum physics, and Walter Brattain, skilled in experiments, worked together on semiconductors. After years of trial and error, on December 23, 1947, Bardeen and Brattain successfully demonstrated the first point-contact transistor. The device could amplify signals just like a vacuum tube, but was tiny, efficient, and far more reliable. By 1948, the scientific world learned of the breakthrough, and in the 1950s, Shockley improved the design, with the bipolar junction transistor, which became the new standard. The 1960s saw transistors combined into integrated circuits, paving the way for microchips and the coming electronics revolution. The three inventors received worldwide recognition, including the Nobel Prize in Physics in 1956. Bardeen stood out as the only person in history to later win a second Nobel Prize in Physics, honoring his deep contributions to science. Brattain's careful experimental work made the first transistor possible, while Shockley's theoretical modeling and persistence pushed the design further. Despite later controversies surrounding Shockley, all three names remain tied to one of the greatest inventions of the 20th century. Together, they transformed not just telephony and radios, but the entire direction of modern technology, laying the foundation for Silicon Valley and the global electronics industry. Today, the transistor remains the heart of modern life. Billions of them exist inside every smartphone, laptop, or even a simple calculator. Microprocessors and memory chips contain tens of billions of these tiny switches, operating so quickly and reliably that they've created the digital world we now take for granted. Scientists are pushing even further, exploring nanotechnology, carbon nanotube transistors, and quantum computing to shape the next generation of machines. From the bulky radios of the 1940s to the sleek devices of today, the transistor has been the invisible force powering progress. It is not just an invention, it is the symbol of humanity's ability to shrink problems into solutions and open the door to the digital age.